something that's been on my mind lately is Eslint's ability to cache, and by extension, TypeScript Eslint's ability to cache. So we'll just start it off with how well can I cache things with TypeScript Eslint?
The problem with caching in TypeScript Eslint is that TypeScript is not designed to be extremely cache friendly at the lint level. In theory, a change in any file could impact almost any other file in your repo, depending on how the files are structured or their types declared. Like you can have global types in file A that impact file B. And there are ways to work on that, say project references or not using weird things that aren't cache friendly, but you don't have to use them. So I personally do not use eslint's -- cache command line. I actually don't remember if that's the name of it. I don't use ESLint caching personally. Great. I will say that performance is probably the biggest concern for TypeScript ESLint now that we've fleshed out the docs side and we worked the configs. So until ESLint is rewritten to have the concepts of like a built-in pluggable type checker or multi-file awareness for caching, my personal priority for perf is going to be using TypeScript APIs that are a little more perf friendly than the ones that we're currently using. Which actually is an ongoing effort that folks can try out now. We have this new command line flag. Sorry, not a command line flag. We have this new parser option called experimental use project service, which switches the APIs that TypeScript Eslint uses for type checking from an old set of APIs, which aren't super perf friendly, to a new set of APIs, which are actually the same ones that language servers and like VS Code use. And we're hopeful that those will speed things up and require less config on users' ends. But it's experimental. We've seen it do everything from like negative 11% performance to plus 50% performance. So 11% worse, 50% better. And then there are bugs with it. So definitely try it out and report the bugs to us because we really want to get it good for V7.
Aside from that feature, how much performance space do you think you actually have in TypeScript ESLint? I mean, I would assume that Prettier or ESLint in general are going to govern the performance that you can get, and you're sort of like a mild baseline. But maybe that assumption is very wrong. Maybe you have a lot to do. So
it's a great question. For Prettier, the way that we work for Prettier is it calls to our parser to generate the structure, the AST as it's called, to use. So I've never seen a performance complaint about us with Prettier. Hooray, good. Prettier is real fast. Props to the project. For ESLint, same thing actually. If you don't count type checking, which is a whole other can of worms. We're real fast. ESLint natively is real fast. And if you don't use type checking, then yeah, the caching for ESLint works, but it's so fast that I've never seen it really be like a big game changer. The perf issue comes when you enable type checking rules because those call to TypeScript. And the TypeScript type checker is very powerful and does a lot and is, as a result, kind of slow at times. They've done a lot of perf work there, but just inherently that is a slower tool than a standalone linter. So at the very worst, if we do everything right, we're still never going to be faster than running the type checker on the files you're linting. So that's kind of the wall there. As once someone rewrites TypeScript in Rust or Go or something, then we'll have a new wall that we can strive towards. But until then, that is our best case scenario.
Yeah, I can't wait for that ESLint rewrite. I like literally yesterday, like the slowest part in our CI right now is ESLint. Not in ESLint's fault. We have lots of rules and lots of code, but it's just so frustrating that there really is no solution. Like I can't do caching. I have to wait for this pending rewrite. It's and like for CI especially, like local, everything's really fast locally. But like for CI, it's like we run these jobs on every commit, every piece of code, and because we're not caching, it's like you can literally attribute like, oh, thousands of hours of compute was spent linting things that didn't need to be linted. So like I really wish that tools would, like caching needs to be a first class thing, because it's like you literally look at it as an environmental issue. It's like if we're mad at Bitcoin for running servers to mine Bitcoins, why aren't we mad at our CI servers for running things that don't need to be run?
Yeah, it's a great point. I will say there are kind of two classes of perf issues that I've seen with ESLint and or TypeScript ESLint. One is stuff that's fixable. There are some common gotchas that people do. There are some plugins that can be slow when configured. So if you're using a plugin, especially us or ESLint plugin import, get a grasp on their FAQs page, see if they have an entry for performance. Because plugins like import and TypeScript ESLint that have to do out-of-band parsing, meaning multi-file shenanigans, those have some gotchas. And then the second category is just, yeah, you've enabled 500 rules and half of them use the type checker, so things are going to be slow. Get wrecked. So good luck with that.
I wonder how much viability there is in like just testing deltas, testing changed files, or if there's any performance benefits there. Remember a coworker of mine at Artsy, David Sheldrick, who was our first guest, wrote a library called Gudetama after the lazy egg, and it was like lazy CI, and it was, a lot of it was the same sort of thing that Vercel's turbo repo project does, is like figuring out dependencies and like running things on the fewest amount of files possible, I suppose. It sounds like the type checking part might be the hardest aspect there because you have to like load everything in. But I mean, with ESLint typically being file by file, that would probably be sufficient, maybe.
Yeah, I definitely would recommend, if folks are seeing slow builds and you have a large repo, highly recommend something like NX or Turbo Repo these days to split it up. You get caching per monorepo component package. So let's take the example of my favorite lint rule, no floating promises. It says if you create a promise, it needs to be handled. Let's say you have an async function, you call that function, you should do something like await it or .catch or try catch or something. Just make sure that if you make a promise that could reject, it's handled. And let's say that every single file in your code base calls to that function. And then you switch that function from async to not async, or maybe it wasn't async and now it is. Now every single file in your project needs to be checked because that function might violate no floating promises in a way it wasn't before if it wasn't async. Or maybe it no longer is async, so you have a bunch of unnecessary awaits, which violates another one of my favorite rules, which is await notable. You should only await something that needs to be awaited. If it's like a number or whatever, there's no point. So that's why caching is hard, because even though you changed one file, if it happens to be that one file that everyone uses, directly or transitively, well, you now have a bunch of lint failures that may or may not be caught in CI. Get wrecked. I would be very interested in seeing someone write a tool that does some kind of TypeScript dependency analysis to see which files need to be relinted. Maybe you could, get away with a small subset there, but it would still be, in the worst case, a lot of your files. So who knows? You both look very upset about this. Am I disappointing you?
I was just thinking about the ramifications of that. I feel like that TypeScript is going to probably have to process the whole project anyway. I don't foresee it like being able to. I mean, unless you're doing, I don't know. I feel like that would be a very, very hard problem. And if someone is really excited about hard problems, then please give that a try.
Yeah, you're right. That's a hard problem, and TypeScript does have to reparse a whole bunch of files to just know that something doesn't change other things.
Yeah, I think it might be. I think the more tractable problem here might be to say, is it possible that this rule could be invoked that needs to like load the full types, and maybe it's a simpler sort of thing. Maybe, I don't know. Anyway, it's an interesting problem though.